So this is from sheet 11 and it's question number 1. And we have this graph. I've got to draw it. If I open up my window and I make my window go from 0 to 2, and I pick up my graph and zoom auto, I can see that it's coming from a stationary point and we're going up to there. And if I analysis to, so I'll get my point of inflection, my point of inflection is there. So it's at 1.154, 1.15. That's 1.2, 1.154, and quarter is about there. So I need to come horizontal, make sure I come up, make sure there's some. So 2.5, that's going to be 2 root 3 on 3 1/4. That's going to be 0, 0. Okay, so there's my graph, badly with the tablet. The region bound by the y-axis and the graph on the line is rotated to form a solid right the definite interval to give you the solid of revolution. So we're revolving around the y-axis. So the volume is going to be the integral from 0 to 1/2 of pi x squared dy. So if I have this as being my y equals, so if I keyboard, copy, paste, and make that equal y, and then solve for x, and then take one of those answers, doesn't matter which one you take, because I'm now going to put a bracket around that and square it. That's what my x squared term is. So that's going to be volume equals integral from 0 to 1/2 of pi times minus 4y on y minus 1 dy. You might have 4y on 1 minus y dy. Pi 0 to 1/2, and that's what v. I multiply it by pi and I integrate it from 0 to 1/2, and that's with respect to y. I get that answer there, which is volume equals 4 pi log base e of 2 minus 2 pi cubic units. Part C, the side of the fish pond to do. Okay, so we want the surface area of the membrane, which will be integral from y1 to y2 of 2 pi x square root of, to have, this is my, that's x. So I need its derivative and then I need to square it. So if I take the derivative with respect to x, that gives me that. Then if I take all of that and I square it, that gives me that expression. So I want the square root of 1 plus this all squared. All of that's got to be underneath the square root. And then I wish 2 pi. And then I need x, which is going to be this expression here. Post. And I wish to integrate all of that from 0 to 1/2 with respect to x. And because I don't have batteries, I've got a PowerPoint that gives me that answer there. If I could do that, then I might go edit, clear all, okay, grab the inside bit of my square root, drag and drop, Zoom auto, there it is. So analysis G-solve integral, and I will choose my integral from 0 to 0.5, and I've got a domain issue. Well, I can see that it equals 0.5 there, so I might go 0.0000001 to 0.5, and that gave me the same answer. So now, I've got, this is my dv dt, and they're asking me for dh dt. So dh dt, where y equals h. Wherever y is, I'm going to replace it with h because my pond, the depth of the water will be the y value, or the height. Okay, so that's going to equal dh dv times dv dt, and that's going to be 0.1 given h equals 1/4. So I need an expression for h. Now I know way up here, this was an expression for volume in terms of y. So that's volume from 0 to a half of 4 pi h on 1 minus h dh. So dv dh is this. If this is an expression for the volume, then the derivative of the volume will be the inside of that. So that was 4 pi h1 on h. So that's going to be over 4 pi h. And what was the denominator again? 1 minus h. So 1 minus h. And that will give you your answer.